Hi, I'm going to explain about common source amplifier with resistive load. As you know that in common source amplifier, the source is common for both input and output side. So it is having source and gate and drain terminals. So when you are giving the input signal across the gate and source, it amplifies the given input signal. Just it amplifies the that is a function for common source amplifier or else other amplifiers. So just when it amplifies the given input signal, but every amplifier is having some band of frequency range to amplify the given input signal using biasing resistors and Q point. We can set the Q point and get the output without any distortion. So just assume that this is the frequency range or bandwidth for the given amplifier. So this is the highest frequency and this is the lowest frequency for the given amplifier. So therefore the bandwidth is highest frequency minus lowest frequency. The main function for the amplifier is just it amplifies the given input signal without any distortion. With here coming to the here using small signal analysis with resistive load. Here you can see this load is there. So then find the what is the input resistance for this circuit, what is the output resistance for the circuit, what is the input impedance, what is the output impedance. Using small signal analysis we can find all these parameters. Mathematically we can find for the you can find the resistance and voltage gain for the given input circuit given circuit easily. So we can say this it is like a same as common source amplifier like except load resistance RL. So we can say this input side R1 R2 is there, output side RD RS is there including RL. There are three resistances at the output side, only input side is only R1 and R2. I am drawing here the small signal analysis. First we need to draw the current, equivalent current for transistor. So that is easy way to draw the small signal analysis part. GM into VGS. Why it is I will tell you. And this is an because GM means transconductance, VGS, but transconductance means output current by input voltage VGS multiplied with VGS cancel, therefore IDS. So that's why they are showing like this. Next, coming to the output side, RD is parallel to RS and parallel to RL. Three are not in series, so parallel. RD parallel to RS parallel to either small or capital, you can assume your wish RL. So this is these are the output resistances. At the output side these are the resistance. All are parallel, not in series. So output side equivalent circuit completed. Now we can show like this. This is an output impedance Z0 completed. Coming to the input side, you can see this resistor R1 is there, R2 is there. Both are in parallel. R1 parallel to R2. R1 parallel to R2. I am assuming this is R1 and this is R2. So this is an input side plus and minus, and this is an input impedance ZL. So like this we need to draw the equivalent circuit for the small signal analysis. Coming to the input resistance, we can find now input resistance are equal. How many resistances are there? R1 parallel to R2. Only two are there. R1 parallel to R2. Or else R1 R2 by R1 plus R2 we can write it. So all are same. R1 R2 by R1 plus R2. So this is the input resistance. Coming to the output resistance, RD is there, RS is there, and RL is there. Three are there. So I am assuming therefore output resistance are not equal. RD parallel to RS parallel to RL. 3 are there. So this is an output resistance. This is an output resistance. So coming to the, we need to find using small signal input impedance. Input impedance equal to input voltage by input current. But input voltage equal to II into Ri by II. II cancel input Ri. But Ri equal to what? Ri equal R1 parallel to R2. R1 parallel to R2. So this is an input impedance. Input impedance. Like this, we need to find the output impedance Z0 equal V0 by I0. But V0 equal I0 into R0 by I0. But I0 cancel and R0. But we know that R0 equal RD parallel to RS parallel to RL. There are three resistances are there. RD parallel to RS parallel to load resistance also we need to consider. This is an Z0. This is an Z0. So coming to here, voltage gain is equal output voltage by input voltage. But output voltage equal I naught into R naught by Ri into Ii. But Ii naught by Ii equal, I can assume that current gain Ai multiplied with R naught by Ri. But R naught we know that we need to substitute Ri, we know that R1 and R2. Like this, we can find the resistance and output resistance and input impedance and output impedance, all the parameters. Mathematical equivalent equations you can easily find by using small signal analysis. Thank you.